Hello everyone, today I'm going to talk about intelligent agents. Let's see further. Contents: agents and environments, rationality, peace, which is nothing but performance measure, environment, actuators, sensors, environment types, agent types. Let's see what is agent. Now let us see what is an agent. An agent is anything that can be viewed as perceiving its environment through sensors and acting upon that environment through actuators. Now let us see human agent. Human agent consists of sensors, eyes, ears, and other organs, and actuators like hands, legs, mouth, and other body parts. Let's say robotic agent. Cameras and infrared range finders for sensors and various motors for actuators. Now let us talk about agents and environments. In this diagram, the diagram of agents and environments is a conceptual representation used in the field of artificial intelligence and agent-based systems to illustrate the interaction between intelligent agents and their surrounding environments. The basic components in this diagram are agents and environments and the interactions between them. The agent function maps from percept histories to actions. The agent program runs on the physical architecture to produce F. Agent is equal to architecture plus program. Now let us talk about vacuum cleaner world. Here is a simple two locations diagram of vacuum cleaner world problem. There are two types, A and B. One is dirt zone and another is cleaning station. Where dirt is accumulated, vacuum cleaner uses suction power to clean surfaces. In cleaning station, designated area for maintenance, vacuum cleaner unloads dirt, recharges and prepares for the next cleaning cycle. The vacuum cleaner autonomously moves between the dirt zone and cleaning station, ensuring a continuous cycle of cleaning and maintenance. Now let us see the percepts, location and contents. Example: A is dirty. Actions that are taken is left, right and suck. Agents function, look up table. For many agents this is a very large table. Here you can see the table. Now let us talk about rational agents. Rationality. Performance measuring success, agent's prior knowledge of environment, actions that agent can perform, agent's percept sequence to date. Rational agents. For each possible percept sequence, a rational agent should select an action that is expected to maximize its performance measure, given the evidence provided by the percept sequence and whatever built-in knowledge the agent has. Now let us see rational is different from omniscience. Percepts may not supply all relevant information. Example in card game, don't know cards of others. Now, rational is different from being perfect. Rationality maximizes expected outcome while perfection maximizes actual outcome. Now let us talk about peace, which is nothing but performance measure, environment, actuators, sensors. First, specify the setting for intelligent agent design. Performance measure: safe, fast, legal, comfortable trip, maximize profits. Environment: roads, other traffic, pedestrians, customers. Actuators: steering wheel, accelerator, brake, signal horn. Sensors: cameras, sonar, speedometer, GPS, odometer, engine sensors, keyboard. Example: part picking robot. In this part picking robot, agent is part picking robot and the performance measure is percentage of parts in correct bins. Environment is conveyor belt with parts or bins. Actuators: jointed arms and hand. Sensors: camera, joint angle sensors. Now, environment types. Fully observable: if an agent sensor can sense or access the complete state of an environment at each point of time, then it is fully observable environment, else it is partially observable. Deterministic: if an agent's current state and selected action can completely determine the next state of the environment, then such environment is called deterministic environment. Episodic: In an episodic environment, there is a series of one-shot actions and only the current percept is required for the action. Static. If the environment can change itself while an agent is deliberating, then such environment is called a dynamic environment, else it is called a static environment. Discrete. If in an environment there are a finite number of percepts and actions that can be performed within it, then such an environment is called a discrete environment, else it is called continuous environment. Single agent. If only one agent is involved in an environment and operating by itself, then such an environment is called single agent environment. Agent types. Four basic types in order of increasing generality. Simple reflex agents with state or model, goal-based agents, utility-based agents, all these can be turned into learning agents. Now let us talk about goal-based agents. Here is a diagram of goal-based agents. A goal-based agent is a conceptual framework in artificial intelligence that models intelligent agents capable of achieving specific goals within an environment. While there isn't a specific universal diagram for goal-based agents, knowing state and environment enough, taxi can go left, right, or straight. Have a goal, a destination to get to. Uses knowledge about a goal to guide actions, example search or planning. I can provide a general overview of the components. The agent perceives information from the environment. It assesses the current state based on the received percepts. The agent determines the goal it aims to achieve. Using its internal program, the agent decides on actions to move toward the goal. The agent performs actions alerting the environment. The feedback loop continues until the agent reaches its goal. The specific design of a goal-based agent may vary based on the application and problem domain. The above components provide a general understanding of the key elements involved in goal-based agent system. Now let us talk about utility-based agents. Goals are not always enough. Many action sequences get taxi to destination. Consider other things. How fast, how safe. A utility function maps a state onto a real number which describes the associated degree of happiness, goodness, and success. Where does the utility measure come from? Economics, money, biology, number of offsprings, your life. Example, why is it important to get a good grade in this course? Now let us talk about learning agents. The term learning agents in the context of artificial intelligence typically refers to systems or entities that can learn and adopt from their environment, while there isn't a specific universal diagram for learning agents. Performance element is what was previously the whole agent. Input sensor, output action. Learning element modifies performance element. Learning agent represents an entity capable of learning from its environment, interacts with the environment through actions, receives feedback or rewards based on its actions environment. The external system in which the learning agent operates provides stimuli and feedback to the learning agent, can be physical or virtual. Actions, decisions or behaviors chosen by the learning agent impact the state of the environment. Perception, the process by which the learning agent receives information from the environment, influences the agent's decision making, rewards or punishments. Feedback signals received by the learning agent reinforce or discourage specific actions. The learning agent's goal is to improve its decision making over time by learning from the consequences of its actions within environment. Now let us talk about the summary of this presentation. Agent can be described by their piece. Environment can be described by several key properties, 64 environment types. A rational agent maximizes the performance measure for their piece. The performance measure depends on the agent function. The agent program implements the agent function. Three main architectures for agent programs. In this course, we will look at some of the common and useful combinations of environment or agent architecture. Thank you for watching this video.